Hello, my fellow YouTubers. This is Roy back again. Here's some Ed Lee Scallon porn for you. Happy Sunday morning. What's up, Tommy? Getting your messages, man. There's my boys. All right, so listen, let's go over this real quick. All right, so we're going to charge these magnets right in front of you. Um, so this is south end, north end. Okay, and it's not too strong. It's probably weak. It could barely hold up this wrench, right? So I'm gonna come over here, and that's a PMH setup right there. And I got it set up that this is the north, this is the south. And I'm putting the south end to the north. And we're gonna go ahead. Okay, so this one should have a strong field about it now. And you ain't shaking that off. Real strong. One thing great about these magnets, they were developed by Ford, Ford's engineer, chief engineer. His name was Ed Spider Huff. If you haven't read about him, make sure you get a book. Go online, just look Ed Spider Huff. He was the chief engineer. And this magnet was designed for the charging system for the Model T Ford, the first Model T Fords that came out. Well, actually, the first ones that came out had dry batteries. And I want to give a shout out to all my boys watching. All right, so I can charge. So we're going to go ahead. Set that aside. So we're going to call it shielding. And the shielding in Ed's machine would work like this. So you would have a metal bar be connected to the chassis of this outside metal casing, as well go over the top of the two magnets that are passing. Okay? Now when that wheel is turning, it is not only approaching a dual magnetic field, but you're going to have this metal bar on top over the approaching magnets and over the magnets that are in this casing. So let me move the magnets a little bit inside the casing here to get a little bit better representation. So the ends won't be sticking out too much. Now, because remember, this box here is a concealed box. It's got an iron casing around it. And you got four magnets in there, and we're going to wrap coil in there and make them a field magnet. So when I figured out that if you read in there, he talks about the iron and how the iron is doing the absorbing. So when you have an iron bar that he has in that picture over the magnets that are approaching and leaving, you're going to have movement in this iron bar. What it'll allow these magnets, these field magnets and permanent magnets, will somewhat have a shielding between these magnets, approaching magnets, and leaving magnets. So there's going to be a magnetic presence without the Lens law effect, because I believe that the is built in as a built-in mechanism to the magnets itself. For instance, here's a magnet, and what I mean by this is here's a magnet. Now the Lens law is when you put a load on the coil that running magnets are going by it. Hey, stop. Too much. Oh, you saying hi to everybody? Okay, so Vinny's saying hi. But anyway, the Lens law will have its own built-in resistance that it's creating and slowing down the motor, right? So same thing is on the magnet. When you go to pull away, it's fighting the strength of the magnet's resistance to not let that go. And that resistance turns into a spurt of energy, whether the energy just goes in the air or back out the coil if there was coils here. So all I want to say is good morning, my fellow YouTubers. I don't know how much of the beginning part of this that you guys missed. All I got to say is one thing about live and being around magnets is that the internet sometimes is not going to work good. So you might have to go back and watch the video. That's right, shielding, the shield comment. So that's when I got back on, right? But if you were watching before the signal was lost, where did I leave off? Because I know where shielding is where I started back off, because that's where I noticed that the internet was not working and it said disconnected. So I was talking for a while with the son of a bitch disconnected. So the key thing is, what I was saying is, why build two wheels? Is this one wheel here is going to enter like a gear. It's gonna enter, go in front of itself, and I'll have to have it positioned perfectly, and I'm gonna have to have one of the wheels out of phase, and that's the key, I think, that I was getting at back to shielding. Shielding allows the phases to be phased out. Their strength is there, but they're phased out. There's the Lens law effect that I speak about in magnets. It is not there. Is its pull strength there? If the wheel is turning and has momentum, it should flow. It should flow. So over here, if you see, what I have going here is you have the gears going inside each other. And the goal is to have both of these wheels connected from a sprocket and a chain. So they're like in a automotive motor where you have your cam and your crank with a chain or a belt. So they're perfectly turning at the same time. That's what these are going to do. And what I displayed with these magnets is that these positive and this negative is gonna, once you move, just get in front of there and move like you're turning like two gears together, the wheel will have perpetual motion. Perpetual motion, because one of the front side of this is turning in the other and moving past each other. So with having two wheels, we should be creating perpetual motion tied together. And by adjusting, because I can control, by using a wire, I can control the strength of these magnets. I can control the speed. And then we can talk about coils all around there. And how do we shield Lenz's law? How do we, this is going to be the pickup videos of my first time YouTubing, watching 5 years ago, 5.5, 6 years ago maybe, but 5 years ago I started watching Mr. Too Tough, and he was explaining, which he did a really great job of how we make electricity up to today and what they have to come across and what they're dealing with, and why you can't get more energy out than you put in because of the drag and the Lenz law effect. And Mr. Angus Wangus was one of the first ones that I started listening to and watching, and really got me into it. And then Mr. Too Tough, he picked it up great. And then here I am, 2018, and I'm combining Mr. Too Tough and Mr. Angus Wangus, and we're going to bring shielding in here because I believe that the shielding is the Lenz law effect to magnets and putting a load on your system. So let's go ahead and take this to the next level. I believe I got this nice stand built right here with the wooden block. We'll get this all set up, coiled out. So one thing I did is I realized that these PMHs with the iron, not good. Not good at all. Let me get one of the iron empties and I'll show you why. See what I did with it. Huh. All right, well, anyway, it looked like this. This is now out of aluminum. So I have brand new spools. So I'm putting new spools on these big bars here. And you know, these big bars are set up, a lot of wire. This whole Ed Lee Scallon wheel thing has been interesting because here I am now from 5 years ago knowing nothing about any of this, but interested, that here now I can go back to Mr. Too Tough when I was watching his video 4 years ago, maybe 5 years ago, or some in that ballpark, maybe, yeah, 4 years ago. Now I understand what he's talking about. Before I didn't. So the interesting fun part this time on starting to do my videos with you guys is that we're going to figure out exactly. I got a wheel counter. This is for making coils, pulse coils, wrapping wire. So this is one of those aluminum spools we're gonna count, has a counter on it. Before we even get into that, we're gonna get into what wire we're gonna use. And here where Sweet 16 with Ed Lee Scallon comes into play, because it so happens that from my experience and my beliefs, my experience has showed me that 14 gauge is too thick of a wire, and 18 gauge is too thin of a wire and too much resistance. That Sweet 16 is the perfect gauge wire for allowing enough amperage current to flow through a wire. And so we'll be basing some of these coils. Now, exactly what the coils that we put around the wheel will be, some will be regular cylinder coils, but most of them will be PMHs. And the reason we're gonna base it on PMH is we're going to be able to use the PMH in different ways. It could be a step-up transformer. And the other thing with the PMH, now that you're going to have aluminum, is I want to be able to wrap the whole PMH into a metal casing. So the PMH loses no energy. It's all trapped within inside. Now, one thing I just want to bring in, back to this. Now remember, this bar is connected to the casing. Remember what Ed says when you have the coil inside, that the prong ends, well, he was talking about a single coil, to where this pole in this core, inner core, will be the opposite of the same size core outer casing. So that means that here we already split it. What we did was we made it a double throw, okay? So this system here is a double throw of what Ed was talking about. And this double throw here will be flopping, even though it's a field coil, a field magnet, okay? It will be sitting in between this field that's approaching and leaving, and this field in this iron bar above the approaching field and the outside casing. So you're going to have your shielding effect, because just using steel iron does not provide shielding effect, because it sticks to it like glue. But when you put that opposing field in this iron, you're going to get that shielding effect. So back to the coil making. The fun part about this setup of back into Ed Lee Skalen is the knowledge that I've learned by doing a lot of reading and research. So we could now figure out how many turns around each one of these coils here, based on some experiments. I upload the videos where I've checked the magnetic strength, the Gauss, on what a perfectly fully charged magnet here does. Then I go ahead and start adding juice to this wire, and I do it in doses from 0 up to 13, okay? And then I look at the magnetic strength, and I'll do a video on that. So there I know what my valley and my peak is of my demand of how much energy or electric has to run through that wire. I don't want to overheat the wire. I don't want to have too big of a wire, so I want to figure out what wire. And this is how this process, I want to show you guys of what this whole build experience is going to bring to you guys, because now I get to do it in a way I've never done it before, and we'll be able to pick exactly what diameter and how many turns. And I'll make a new video, and we'll do one on doing a test sample of like, say, 20 turns or 10 turns of coil wire on this little magnet, and we'll hit it with whatever voltage we're going to use. And that voltage will, how do you figure that voltage? So we know we're going to use up to 12 volts, basically 13 if it's a car battery. So we have some basis there to figure out, there's our max, there's our peak, and then our valley 0 volts. So then we can figure out what wire to go from there. That would be on these here, but that is not anything to do with the PMHs now, because the PMHs, we can do one where it's 12 gauge or 14 gauge, and the other one where it's 22 gauge or 24 gauge or 26 gauge or 30 gauge. If we wanted to get high voltage out of one of these, we could. Step up transformer, easy to do. And I like to do it just to see what we can get out of it. The key thing is you count how many spokes we got all the way around, and we're going to start off by counting the spokes, north, south, for one full revolution. And then we're going to pick a speed. And that speed is going to be a constant. And I think Um, the, the goal here is to get both wheels going, connect them together, and see if my concept works. If the concept works that one's chasing the other and you get it going and it goes, and then we start using a potentiometer of some sort or a voltage switch. Then we start increasing voltage to make the magnet stronger. Then we're on to something. If if we don't get anything, but we just get where they float by each other like a good balanced wheel, then from there, if there's no resistance built in because there's two wheels and it just moves kind of freely, but it doesn't chase itself, then we'll go ahead and put a belt around one of these and we'll hook electric motor. Then we'll check the RPMs and get it to an RPM that we're going to use as a basis. The whole thing is the frequency, guys. So what frequency are we looking to be banging at? Now, if we're looking to have this make energy for running my workshop per se, then we're going to have to make sure it's spinning at least 600 RPMs, okay? At least 600 RPMs. And we can use that as a gauge. So frequency would be the start, and that is the gauge of what size wire on what coils. Now, there's another thing I want to try out is several coils that are going to be around the wheel are we could have those coils in a PMH split to where, like I was saying, one's high voltage, one's a primary. But what we could do is have it to where each PMH takes its back EMF and dumps it into the capacitor of the next one. So basically, we could be creating a power conservation from one PMH to another as it pulls. It's transferring its back EMF power into the charge coming in of the next PMH. So there's a lot of things here that's fun with this. Learning exactly what voltage, what wattage we want, how to control that, how to make that happen. The shielding part, the fact that we're going to be keeping a constant steady, and that's that DC steady with the magnets. So with the magnets, we bring to the table something to play with. You guys got me? We got something to play with here. Then all of a sudden, we're going to go ahead and we're going to wrap these with some wire. We're going to control, without even heating up, what voltage we want to send through them, and if we want to get in some spurts. Now remember, that was turning like that. Like two gears. For some reason, the gear thing in my mind reminds me of the universe, to where one big gear, the universe, and how the Milky Way and how the galaxy and then the galaxies and how there's one big cog wheel and smaller wheels, and they're all shooting, moving in cymatics, without a doubt. And this kind of reminds me of that. And there's, you got a electromagnetic field that's happening from the sun to its solar system, and there's like one gear that's controlling littler gears in the solar system. Then you got your whole damn Milky Way, and then you got your galaxy there. Yeah, these are getting stronger. Another thing I wanted to let you guys know is, since I put the wire on this wheel, it really holds its strength. Super strong now. And I think that's because this clover ring and this ring here, and even this ring, gear ring here, is like the perpetual motion holder with is caught in this clover and this ring and this gear ring, and concentrated. So it feels like now that this wheel is stronger just with the wire on it because there's trapped energy in there. That's all I'm saying. And if you want to reflect to Ed Lee Scallon's picture of him in front of the wheel and why he has all that iron in that picture is because of what I'm saying here, of that trapped energy. So if he's trapping the energy in all the iron, there's a lot of reservoir of magnets that can be shifted and concentrated. So hopefully you guys liked the video. Live thing, the cutting in, cutting out, not too sure about. But hopefully I'm going to have to sit back, watch this video, end this little show here for you guys. Hopefully you like it. I couldn't read any of the comments. I have the damn thing hanging upside down. I don't know if I could have my laptop running as my phone's running. I'll figure this shit out. But hopefully you guys appreciate the video and having the steps I've taken to go into the process here. I'm really proud of, because it's all about the numbers and knowing exactly what size coils, what size wire, and what pull strength you're looking for, and layer after layer after layer. Thanks, my boy Bob Ross. Peace out. All right, so now I'm looking at the damn. It stops and goes, and you have to almost go back because YouTube will upload this video once we hang up, and they'll put it on there itself and do whatever they do. So I don't know exactly what you guys seen by watching live. I'm not too into it too much, but all those comments you guys left, I never read one, and they disappeared, and I'll never be able to see them, which sucks. So that's I needed the phone to be hanging so you can see down into everything. Hopefully, it was a good visual. You can wait, Tommy. I can just post the live into comment section. How do you do that? That's what we want, because if you go into live, like when they upload it, the comments don't even show up. Wow, the first 14 minutes I lost? Well, that's what we're going to see in the video. I guess, because unless the video just chops it and whatever you said just is gone. I don't know. But, all right, well, peace out. Thanks for watching. Hopefully you got to understand where I'm at with this whole thing. And Tommy, be getting your emails. Read your comments. Keep up the good work. You should post me up some of your work too. Talk to you later.